3D and 4D textile printing presented in Smart Textile and Emerging Technology STET 2024 International Virtual Conference on 5th to 6th December 2024 by Textile and Material Research Limited, New Zealand. I am Dr. Asim Kumar Raichaudhary, retired professor and HOD, Government College of Engineering and Textile Technology, Srirampur, West Bengal, India 712201. Email akrc2008@yahoo.in. Orchid ID 0000015475-876. The textile printing. The word printing derives from a Latin word meaning pressing. Normally it is carried out at the fabric stage and sometimes at the garment stage. In dyeing, colorants are applied uniformly. In printing, colorants are applied in selective portions as per design. In both dyed and printed fabrics, the colorant should be physically or chemically bonded with the textile fiber to withstand washing and rubbing. Conventional methods of textile printing. The most primitive method is hand block, where printing is done with engraved wooden blocks. Roller printing is printed with mechanically driven copper engraved roller. It's high production and very durable machine. Hand screen, in this case printing is done with small screens made of polyester or nylon fabric. It is a sort of stencil printing. Rotary screen is a mechanized version of screen printing. It's high production and very versatile. Next is transfer printing. In this case, in very special quality of paper is printed first and then transferred to the fabric by heat treatment. And digital fabric printing, it is very similar, specialized version of inkjet printing commonly used for textile paper printing. Most of the conventional textile printings are two-dimensional. Additive manufacturing is the technologies that successfully join materials to create physical objects. 3D printing is a type of additive manufacturing invented by Dr. Hideo Kodama 1981 as patent application for a rapid prototype device. 3D printing is now becoming used in almost all industries such as consumer product, eyewear, footwear, textiles, furniture, industrial products, dental products, artificial body parts, architectural scale models, reconstructing fossils, replicating the ancient artifacts, reconstructing evidence in forensic pathology, movie objects used in stage or screen. 3D printing in textile industry. Textile industry is a major consumer of water and material resources. It has massive environmental footprint and it is extremely unsustainable. 3D textile printing reduces required resources, requires less raw materials, chemicals and water, produce much less waste materials, reduces energy consumption and cost, and enhances design freedom. Multi-material printing provides innovative material design. 3D printing allows for the creation of complex and intricate designs, becoming popular item for fashion and textile at recent years. 3D printed garments. Conventional garment making involves cutting and sewing flat materials. 3D printing allows creation of complex and intricate design not possible using traditional methods. Figure shows 3D printed special fashion garments. 3D printing can create highly customized and uniform products tailored to the need and preference of the individual customers. that is a more personalized approach to fashion and textile, becoming increasingly important in today's market. 3D printer can create a fabric-like material as shown in the figure to create unique and intricate designs impossible to make using traditional methods. 3D printed garments. 3D printers in fashion can be used to support the different parts of a whole design like embellishments, accessories and buttons. Small end-use accessories can be easily integrated in just few minutes using 3D printing. Such materials with very good and flexible nature as TPU can be used to add precious pieces or unique embellishment onto the garment. Next, zero waste 3D printed personalized skirt was produced much less than 1% waste during production with recyclable filaments by Julia Devia. Smart textile materials. 3D printed textiles are integrated with electronic components and sensors to create smart textiles and wearable technologies to incorporate functionalities such as temperature regulation, biometric monitoring, gesture recognition, and haptic feedback, enabling application in the healthcare, fitness, gaming, and fashion technology. Proximity days or spider days shown in figure was designed in the context of the COVID-19 health crisis. That is, the days includes different sensors to detect movement. If a person gets too close to the wearer of the dress, the base will expand to create a kind of barrier. Uses of 3D printed textiles. Customized fashion and apparel, automobile interiors, home furnishing, protective clothing, medical devices, and performance sportswear. Architecture and construction, artists and sculptures, smart textiles and wearable technologies with temperature regulation, biometric monitoring, gesture recognition, and haptic feedback for applications in healthcare, fitness, gaming, and fashion technology. Advantages of 3D printing: customization and personalization of garments, higher material efficiency, innovative designs and functional integration, avoid wastage due to cutting and sewing, creation of complex and intricate designs, faster innovation and faster manufacture, utilization of low-cost plastics and concrete, single process, increased efficiency, ideal for quick prototyping of products, embedding sensors into smart textiles, work with specialty materials, specialty parts and products, environmental benefits. Disadvantages of 3D printing: complex processes, specialized equipment, expertise required, insufficient strength and durability of products due to layer by layer formation. 3D printers may have accuracy issues. Batch to batch variation of the products may be possible. 3D printed products may require post-processing, increasing cost and time. Limited suitable textile material for 3D textile printing. Surface quality vary from traditional textiles. Unusual feel, appearance and comfort of the final product. Suitable 3D textile printer manufacturers. Stay-Seals US, known for FDM and polyjet technologies. Shima Saiki, Japan, ultrasonic additive manufacturing, UAM technology. Electrolume, 3D printing seamless wearable fabric from a liquid solution of synthetic fibers. Textile technology, printing of multi-layered textiles with customized properties. Voxel 8, multi-material 3D printing platform for printing electronic circuit directly onto fabric substrate. Acid Bulmar 3D textile printing solutions tailored specifically for the fabric. Principle of 3D printing. First stage, designing of 3D model using CAD, defining the shape and structure of the object, exported on STL or object file to printer software, and slicing the digital model into layers. Next stage, layer by layer printing as per design, depositing molten or dissolved materials onto a platform. Different types of material can be used, including plastics, metals, ceramics, and even food. The choice depends on printer and intended application. 3D printers come in various shapes and sizes, small as desktop, medium for textile and other consumable printing, to very large for industrial purposes such as creating 3D printed houses. Types of 3D printers. The popular types are fused deposition modeling (FDM), stereolithography (SLA), selective laser sintering (SLS), multi-jet fusion (MJF), digital light processing (DLP), continuous liquid interface production (CLIP), material jetting photopolymers (MJ), binder jetting, sheet lamination, directed energy deposition (DED). The choice depends on factors: the desired properties of the textile object, the complexity of the design, and the available budget and resources. FDM or FFF and DIW 3D printers. FDM, that is fused deposition modeling, or FFF, that is fused filament fabrication. In this case, plastic filament is unwound from a spool, melt and flow through a heated nozzle in horizontal and vertical directions. This is very useful for manufacturing prototypes and models. Direct ink writing (DIW). Filament-based suspension or inks are continuously extruded out of the nozzle under controlled flow rates by piston, a screwing system, or pneumatic pressure. Layer by layer printing and 3D objects are thereby built. SLA and SLS 3D printers. Stereolithography, that is SLA. Light sources cures liquid resin into hardened plastic, offer fastest speed, highest resolution and accuracy, surface details, and smoothest surface finishes, printing on versatile materials. Next, selective laser sintering (SLS). A laser acts as a heat source to sinter powder material, nylon or polyamide, automatically at points in space defined by a 3D model, binding materials together to create solid structure. Multi-jet 3D printer. A sweeping arm deposits powder and an inkjet equipped arm applies binder selectively on top. A detailing agent is applied for precision. Finally, thermal energy applied to cause a chemical reaction. Direct metal laser sinter (DMLS) also utilizes the same process but with metal powder specifically. Digital light processing (DLP), oldest form of 3D printing, uses lamps to produce prints at higher speed than SLA as layers dry in seconds. Continuous liquid interface production (CLIP) uses VAT photopolymerization. A sequence of UV images projects across a cross-section of a 3D printer part. The part is then baked in a thermal bath or oven, causing chemical reaction to harden. Material jetting photopolymers (MJ). The method jets photopolymers or wax droplets through a thermal or piezoelectric mechanism onto a built platform and solidifying with ultraviolet light. Photopolymer resins are extremely durable, highly rigid and high temperature resistance. Properties are similar to common FDM 3D printing with thermoplastic materials such as ABS, PLA and PC. Binder jetting. Adhesive binding agent deposited on two thin layers of powdered material. During the binder jetting, the 3D printer head moves over the belt. Binder droplets deposit on platform similar to 2D printing, layer by layer. Sheet lamination. Sheet lamination binds material in sheets through external forces and welds them together through layered ultrasonic welding. Directed energy deposition (DED). DED systems use an electric arc, plasma, laser or electron beam to melt metal feedstock, wire or powder into a molten deposit pool. Inkjet based 3D printers. These printers are also used for industrial scale transformation from 2D graphical to 3D structural print. Continuous inkjet CIJ or drop on demand DOD 3D printers. Both techniques produce uniform droplets from the print head. Printing materials. There are many types of material can be used. Most important are acrylonitrile, butadiene, styrene, plastic, ABS plastic, carbon fiber filaments, conductive filaments, flexible filaments, metal filaments. Post-printing. The printed parts may require, after printing, rinsing in isopropyl alcohol to remove any uncured resin, post-curing to stabilize mechanical properties, manual work to remove support structures, or cleaning with compressed air to remove excess powder. Specific applications require finishing by machining, priming, painting, fastening or joining. 4D printing. In 4D printing, the printed object changes shape with time, temperature and some other types of stimulation, allowing customized printing of shape changing and shape memory materials. Potential for new application and usage for plastic, composites, metal, new alloys, composites, etc. In 4D printing, the material used possesses the ability to undergo predetermined changes in response to external triggers, transforming the printed textile into dynamic. Shows an example of 4D printing. Shape programming. A specific structure in the original is shown in the first box. When it is heated, it gets twisted, and on cooling, it takes a structure, compressed structure. Now, when it is again heated and the twisting opens up and it brings to original structure after cooling. Challenges and future trends. 4D textile printing faces challenges like the development of advanced smart material, precise control over transformation behaviors, and scalability of production process. 4D textile printing enables the creation of dynamic, adaptive, and responsive textile structure that blur the boundaries between form and function. Thank you for listening. First figure shows a 3D printed fabric, and second figure shows 4D printed that changes shape or automatically reassemble.